Greetings, wonderful physics students. Students of probably my course, Physics 221, fall semester here in 2020. So I'm making this video here to just get you started or give you a hand on your homework for Unit 1, the first homework set, and the first week here. So we're going to take a look at problems 5, 7, and 8. So I already started writing some stuff down here for number 5. Let's see, what does it say here? A particle moves according to that equation. X is in meters, t is in seconds. Find the average velocity from the over this time interval. So here's how velocity is calculated. Right? It's delta x over delta t. If you're using x here to represent the position of the particle, all you need to do is calculate an x value at this time, an x value at this time, and the difference between them is your delta x, and the delta t is the difference between those two numbers. And that's enough on that. That'll probably get that one done. Let's take a look at number 7. Okay, a particle is moving at 62 meters per second in the positive x direction. So there's an initial velocity given in the positive x direction. Now in the homework that I have, it says 62 meters per second. However, yours could be something else because I set the homework to randomly generate different values. And then it says 15.8 seconds later, the velocity decreases uniformly to 0. So I would start by drawing a velocity graph. And the first point on that graph, right, when t is 0, the velocity is given in the problem. And then sometime later, again, given in the problem, the velocity is 0. Now, these are just points on the graph. If we connect them linearly, which is okay, we have made a constant acceleration assumption, which is just fine. And now just calculate the slope of this line. All right, one thing about this video too, I'm getting used to a new computer and it has palm rejection, and sometimes you'll see stuff like this show up where the palm rejection isn't working perfectly, but it's working fair enough. That's probably enough on 7. So let's see, number 8. A 50-gram super ball moving at 28 meters per second bounces off a wall and rebounds at 15. So in the example I've been given, we've got an initial velocity of 28 meters per second, rebounds at 15 meters per second. It is very likely that you will have different values here and here. Again, I would recommend you draw the velocity graph for this. At t equals 0, the velocity is some positive number. Now when we're sketching graphs, by the way, you notice that I just kind of basically put this down wherever I feel like it. And you know, for a sketch, that's perfectly fine, but I've kind of set a scale now. So this distance here is approximately 30. When we plot this thing right here, it's 15, and keep in mind it's in the other direction. So sometime later, we don't know the time, that velocity is about minus 15. I'm trying to kind of honor my scale here. 30 is roughly that, so I tried to put the minus 15 about where I think it should be. I'm going to go ahead and make our constant acceleration assumption. And now there's a delta t mentioned in the problem. In my example, it says 3.50 millisecond. Now milli, this means 10 to the minus third. So this is 0.0035 seconds. So that's going to be your delta t. When you find the slope, that's going to be this distance on the graph, and there's your rise. Keep in mind you're going down by a certain amount. So anyway, just an introductory video meant to give you a little heads up or head start on your homework. I hope that this has done that for you. Have a great day.